Okay, so thank you very much, Enrico, for your introduction, and thank you for having me here to talk about this this topic that I'm really kind of passionate about, which is visualizing geospatial data with R. So just to give you a bit of my background, so my background is actually in chemistry and chemical engineering. But during my PhD, I started programming in R, and I started using R as the main tool for data analysis. And this is how then this became my job, basically. So today I'm going to give a bit of a bird's eye view on the landscape of visualization, data visualization with R, but really specific to geographic data. So making maps, basically, to be clear. There's like a ton of packages now available for both like importing and manipulating geographical data, and also a ton of like ways to visualize them. What I'm gonna focus here is mostly on the tip of the iceberg of this vast landscape of packages, which is in terms of like importing and manipulating is, I'm gonna speak only about the SF and the raster package, basically, which are now the main tools for anything that has to deal with geographical data. I'm gonna do a brief introduction on how this data looks like, and then I'm gonna just jump into the visualization part. So with ggplot and all the others, other packages. When we talk about spatial data, actually we need to really separate two types of data, which are really different from one to another. So one is vectorial data and one is raster data. So for vectorial data, which is stored in a very different way, we're going to see soon. The main package to use nowadays, it's the SF package. And for raster data, when using raster data, the package is called raster. How does like a vectorial data look like? So when I talk about vectorial data, we talk about features. This can be point, lines, or polygons, for example. So points, if you think of like the location of a shop location or your house location, this is defined by a longitude and a latitude coordinate, and this is like a specific point in space. So instead of having Cartesian coordinates, we have latitude and longitude. We can have features that are lines features, which if you think of like roads, train tracks, rivers, ski routes, anything that basically it's a sequence of latitude and longitude coordinates. If this sequence is then connected, so the beginning and the beginning point and the last point are the same, this is a polygon. For example, a country is described as a polygon, so country borders, buildings are described as polygons, geological areas, for example. So these are all, this type of data is used when we have defined borders for whatever feature we want to describe. In R, we use the SF package. And so to give you an example, the main thing is that you have to think that, so this data is really tidy and it's really easy to work with because the class, so when you import this type of data, the class, it's a SF data frame. And the only difference between a table and this SF data frame is basically that it will contain a geometry column. This geometry column is really the column that contains the geometry of our features. These are contained as list, as you can see here. So it's basically a nested data frame. And the really good thing of like using this SF, this SF package is that basically your data is really tidy, and so you can really use simple deep layer tidyverse method for data wrangling, for filtering, selecting, because you can basically select by other columns and you will keep only certain features. So it's very easy to work with. But then there's this other type of data that it's used for like continuous variables. So for example, before we thought about like having borders, having defined borders. If you think of images from the satellite, imagine like a satellite image of air pollution. I'm a bit biased here because that's what I'm used to work with. So satellite images of air pollution doesn't know borders, for example, doesn't know that between France and Switzerland, there is a border, so it's more a continuum. So the best way to define it, and it's more like dividing space in a grid with equally spaced cells. So we know like the dimension of each cell, we will know, we will know the dimension of each cell. Sorry, just a question. Do you see the title of my slides, or do you also see the Zoom bar?
We can read rasters.
You can read it?
Rasters, yes.
Okay, no, because I can't, but it's good if you can. So basically these rasters are made of equally spaced cells, and if we know we just need to know basically where is the origin of this raster, and then we'll know where to put it in space, because we just need to know how many columns, how many rows, and by knowing that each cell is equally spaced, we know where to put it in space. So it's the other way we can define spatial data. And when we deal with this type of data, we use another package which is called raster, and it's not anymore the SF package. As I said, this is really common when you have continuous variables like population density, air pollution, surface temperature, and for satellite data. So this is just like a very brief introduction on like what you need to know to the very basic of what you need to know to then use and visualize your spatial data. And the main two libraries are SF and rasters. Stars, it's a new package that basically it's meant for raster data, but when you have multi-layer rasters, so for example, you have a multi-dimensional data set where you have one raster for each time in space. So if you want to do time series of rasters, but the idea it's always, it's like raster, so there's not much difference there. So now let's go into the visualization part. We will start with, for the visualization, we will see different libraries. The main will be here ggplot, but we also touch tmap and other interactive and non-interactive packages that are more of a niche package at the moment. So just for you to know, we will start by importing. Let's think that we start importing data into our console, and then we use the SF package, which st_read to read all my data, which is the shapes of lakes, country, districts, and then I also read in a raster, which gives me the relief of the mountains in Switzerland, and for this I'm going to use the raster package, and then I'm going to also get the income, like a table with the income for each mean income per capita for each district, so that I can plot it on the Swiss map. But you don't need to really know this. It's just to give you a bit of perspective of what I'm doing here. So I start with ggplot as the jack of all trades for plotting basically anything you can think of. ggplot is actually well adapted also for plotting geographical, geospatial data. So, for example, when we think of when we have vectorial data, when we use the SF package. This SF package comes with an extra geom that can be used for in ggplot, which is geom SF. So, and with this, basically, it will exactly plot the geometry column in our SF data frame that we have imported before. So here, ggplot, if you know ggplot, I kind of assume that you know a little bit how it works. You plot things by layer. You can stack layer on top of each other, and the same thing is valid when you want to plot geographical data. So you can start by a layer, basically, for example, start by country, then you can plot on top lakes, and then you can plot on top another shape, which is district. How do we then actually make a thematic map like this one, in which each district has a different color? Is by just adding an aesthetics, which is defined by an attribute of each district. So when we merge, imagine that we have information by district of, as I said, mean income per capita, like per year. We can then merge my SF data frame, which contains the geometries of each district, with my attribute data, which is income. And then I will be able to just define an aesthetic with the fill, which is equal to the attribute data. So it's actually like, once you understand that the geometry is stored into one of these SF data frames and how it works, it's very easy to create thematic maps. We've seen even before the presentation of Benjamin's presentation, a thematic map which might have been done with ggplot. So this is really like, ggplot is really easy to use with this type of data, as you can see. When we have raster data, we can also use ggplot. We just need to actually transform first the data into a matrix, which is then more easily read by ggplot. But once we have done this, it's fairly easy to plot it, because the raster package basically introduces just a geom raster that we can use with this type of data, which is actually built in ggplot too. And this makes it very easy to plot. Then, of course, since it's ggplot and it like works in layers, we can stack layer on top of each other. Here, for example, I have the raster layer at the bottom, and I have stacked on top of it the country border, then the lake border, and then the districts. On the districts, actually, sorry, I forgot to put it here, but there's an alpha. So I decided to give a bit of transparency to it, so that basically you can see the relief at the bottom of each of the layers. So like the advantages of using ggplot2 is that since like most of our development is now into the tidyverse universe, let's say. So our studio, I think it's funding mostly that. This means that there's a lot of packages that are fairly that are well adapted for ggplot. And one example is, I wanted to actually press, sorry, I just needed to press play and it didn't work. I just want to show that, yeah, so basically it's easy to then create animations like this, because you have access to a package that it's called ggAnimate, for example, and this really allows to easily integrate animation into all your ggplot, and maps is no exception. Another package that it's nice to use if you want to basically make normal ggplots, but faceting each grid, instead of using facet wrap, faceting using geofacet, in which each facet actually corresponds to a geographical feature. For example, here is we have a facet for each canton, and then the facets are placed in space, mimicking the geography of Switzerland. And this is possible because we are using ggplot2, and it's it's an extra tool that it's available for us. Another possibility that we have if we use ggplot is to use also a package that is called Patchwork, which previously, well, it's basically very similar to cowplot if you're used to work with that when you want to put plots together. But this is kind of the newer version of cowplot. And it allows you to make very easily create inset maps. So this is when you want to put two maps together to give one that it's little and gives you a little bit more of a perspective of where is the geographical area you are zooming in. For example, the European map on the left. This is commonly used in the newspapers, for example, when they want to, for example, here, imagine you don't know where Switzerland is, then you could use such an inset map to highlight the area of Europe that you're highlighting. So basically,
Giulia, excuse me, may I interrupt you 5 seconds just for a communication for the participants? Just to inform you that at the bottom of the screen, there is a Q&A functionality. So if there are any questions, please use it, and then I will ask those questions to Giulia at the end of her presentation. Yeah,
thank you, Enrico.
You're welcome.
So basically, the idea really with ggplot is it's nice to use it because it really well integrates with the whole ecosystem of Tidyverse and all the packages that are written for ggplot. So even though it's not like meant and built for maps, it still has all the features that are needed to create maps. Here I just give you an example in which I still use GeoMSF, but nowadays it's really, you can see online a lot of these examples where you can download data from OpenStreetMap using the OSM package, and then it's very easy to then plot them in ggplot using, because they basically are stored as SF features. So it's all very easily implemented. So this is, for example, a map of Geneva that I downloaded, in which I downloaded the features from OpenStreetMap. So I downloaded the roads, the small roads, the rivers, the water, and it was like basically each layer was stacked on top of each other using ggplot. There is actually also another, so there is another package that it's similar to ggplot, but it really cartography specific. And it's the idea on which it's built is really similar to ggplot. It's still, we work basically in layers. There is even the plus sign in between layers. So it really reminds us of the ggplot. And somehow it's even actually easier to create map with it because it's really created for it. And the only issue is that things like Patchwork, things like ggAnimate, they don't work with it. So I think it's nice when you want to create fast maps, but then if you want to have a bit more decision on where to put things, and if you want to integrate extra libraries, you cannot really use it. But for example, here, just show you like this piece of code, exactly this, will give you exactly this map. Here I'm reading the OpenStreetMap. This is all code from TMAP. From TMAP tools. So I'm reading the OpenStreetMap. I'm telling like to read the area that it's given by the country shapefiles. So by the shape of Switzerland, he sees the shape of Switzerland. He creates a rectangle around it, and then downloads the OpenStreetMap that you can see below. And then if we go at the second part of the code, which is TM shape. So we first use TM shape, in which we call the layer that we want to plot. Then we actually plot the layer with this TM RGB, since it's a RGB and not raster, just because it's in 3 colors. So there's actually 3 layers that you download, one for red, green, and blue. So we use TM RGB for that purpose. And then we can just use TM shape where we call the district data, the one that we have seen before, for example, that we were plotting with ggplot. And then we can just plot easily the mean, which is the income that we were showing before also. And this creates automatically a map like this. The really interesting feature, if you ever done thematic maps before, is that, so usually when you have a continuous variable, for example, this mean is a continuous numerical variable that contains the values of the mean income for each district. If you use ggplot, you have to manually slice it into categories, so that you have a bit of if you want an even distribution of colors around your map. So you usually use quantiles, for example, to slice your numerical variables into chunks that contain the same number of data, and then to each category you have a color, you give a color, and then these colors are evenly distributed around. In TMAP, this is all done automatically. Here we have in TM polygons, we just have to say style equal quantile, and he'll know he has to slice this numerical variables into quantiles, and does it automatically for you. The code is slightly different. We can see like palettes equal minus Peridis. So it's a bit different than if you're used to use ggplot2, but somehow it's still very understandable if you come from that world. The other really interesting feature of TMAP is that with one line, which is this TMAP mode view, you go from static maps to interactive maps. So here I go back to this so that I can click on it. So for example, here I created just a GIF of an interactive map, which is the same map as before, in which I have just added districts to the map that is automatically created with TMAP mode, which is this bottom map. Plus I added the lakes on top of it just to have it colored a bit more, that stands out a little bit more. So let me go back into play mode. So these are really the advantages of TMAP. So it's very fast to use. It's pretty easy. I think you can do a lot of customization on it. The only issue is that you basically have to learn whole new functions and everything. Instead, if you use ggplot, for example, if you're used to use theme and scales, and you are used to customize your plot like that, then you have to a little bit switch. It's like switching a little bit of language. But so, like, talking about this interactive features that are really actually useful when we want to embed our maps onto Shiny apps, for example. I think for till now, the king of the place is leaflet. Leaflet is really how we create interactive maps. And for here, I'm going to actually switch. I'm going to show you an interactive map that it's online that I created some time ago for the WHO. And here you can see it's a leaflet. It's a leaflet. I mean, I use leaflet, and so this map is done using leaflet, and you can see it's really easy to navigate it. You can even have pop-ups, so you can press some features and you will have more information that is given to you. Then it's really easily integrated into Shiny apps. For example, here, it's very easy to integrate this this is not working anymore. I guess it's loading. It's very easy to integrate this type of, a leaflet map inside your Shiny app, also because also leaflet is done by layers, and you can even give an ID to each layer. So it's very easy then to give Shiny command, like something like this, and then have plotted only the layers that you actually want. This map, this Shiny app, for example, it's online. If you want to try it out and see what you can do with leaflet. You can do much more than this, but this is really an easy example and easily implemented, and you can see how easy it is to integrate these tools together. Another option that is now getting really
Giulia?
Yes?
You have only a few minutes left.
Yeah, I'm almost done.
Okay.
Yeah. Thank you. Sorry for. So the last library. Well, basically, the last library I'm going to show is this MapDeck, which is the pimped version. Oh, sorry, it's the pimped version of Leaflet, which nowadays is getting really hot, I think, on online. And you basically have the same features of Leaflet, but you have much more you have more types of visualizations that are available. All this 3D visualization, for example, that are very nice and that now you can see very often online. The really last, I'm almost done, the really last library that I want to show you is a library that it's meant for raster data, but only for usually use it for only elevation data. So when you have a raster data that it's made of elevation elevation values, for example, this is how your raster will look like, and your raster data will look like on the left. So it's really just a matrix giving you elevation for a certain grid, for each grid. And from this, you can easily create something like this, which kind of looks like a picture. And from this, it's very easy to then create a GIF. This is the code that this is really just the code that you would do to create such a 3D view of a map. And then you can easily use a 3D. Yeah, it can be useful if you work with elevation data or data that should be visualized in 3D. And with this, I thank you for your attention. And this is my contact. And if you have more questions, we'll see each other, I guess, in the extra room that the organizers provided us. Also, as part of the Extension School, I would like to also tell you that we are currently hiring. So if you're interested in teaching data visualization or teaching this type of or like data wrangling, if you're into teaching and into data analysis with tidyverse and ggplot mostly, you are more than welcome to check the positions that are currently available. And And if you want more details, or if you're interested in this topic, two really good resources are, one is Geocomputation with R, and the other one is Fundamentals of Data Visualization, which are really kind of comprehensive resources of
I'm sorry to
material.
interrupt you, Giulia, but we are already over time.
Ah, sorry. Yeah, I'm done.
Okay, awesome.
Thank you.
So thank you very much for your presentation.